All right, settle down, class. How's
How's
everybody doing today? Welcome. Settle down. Okay, that's enough. All right, great. So, today we're going to be talking about estuaries. All right, our objective of the day is to understand why and how estuaries are important marine systems. Okay, first we're going to have a little discussion. And then I will provide you guys with some content. We're going to go on a virtual field trip, believe it or not. Okay, so that's pretty exciting. And then your assignment is to research the chemistry, the biology, the physics, and the geology of a specific estuary. Now, is everybody present?
Present. I'm chillin', bro. What it do? What it do? Chill. Accounted for.
Excellent. All right, class. So our virtual field trip today is to Brownsville Nature Preserve.
Oh, yay.
It is a 1,250-acre historic farm that was formed when scientists and the community alike decided to preserve and protect the ecosystem.
Whoa, there'll be like cows? Is it like that type of farm? No, you silly imbecile, it was a farm. The Nature Conservancy purchased it to protect it. Come on, Blake, get with the program, dude. Come on, bro. I can't wait to see the geomorphology.
And now it's important to note that estuaries, right, are transitions from terrestrial, from land habitats to marine habitats, right? And so there are going to be lots of zones of transition or lots of scenes of transition, right? And so why, class, are estuaries important?
Got bees and birds and plants and protozoans.
Blake, how do you know about protozoans?
Huh? Oh, saw it on a Nat Geo documentary, bro.
Well, yeah, okay. Well, I guess you're right. But why, okay, why is the species richness and the overall biological diversity and abundance, why are they so much greater in estuaries compared to other habitats?
Well, according to my calculations, let me do it real quick. The Nature Conservancy at Brownsville is very close to the mainland. And, depending on the watershed size, lots of nutrients could wash into the system. Hold on, broskies. Use my app. Calculate the size of the watershed, how much rainfall it receives.
Well, that's impressive. Get back to me on that, Philip.
Mr. Carlson, the real reason why there's so much diversity is because there are small changes in the topography and the bathymetry. Alright? These changes create small micro-habitats that only certain species can occupy. Species tend to favor environmental conditions and thrive best in those habitats. Things like competition, predation, behavior, larval disperser, or tolerance of organisms, they control these locations.
Nailed it!
Alright, well, looks like we made it, gang. Welcome to Brownsville. So I want you guys to go out and record something that you find interesting. John here. I decided to stay in the car for the time being, take a look at the landscape from the aerial. My geologic perspective requires me to take a look in the air first, take a look at some things. So let's type in, yes, this is where we'd like to go. Alright, take me there, Google. But we are actually going to be taking this path right here, down to this wetland. Some tidal influence, it looks like. A little peninsula right here. Here's a big lagoon. Okay, so that's the situation. I'd also like to check out some soils. I love me some soils. What type of soil do we want? Oh, bloody, look at all the different types of soils. Let's zoom right on in here. Okay, so here's our wetland. Right, so let's take a look at what type of soils right here. I'm on Soil Web. At this location we've got Magotha Fine Sandy Loam. We've also got some Chincoteague Silt Loam. Got some Bunn Sandy Loam. And some Bojack Fine Sandy Loam. So let's go take a look if we can find those in the field.
Let's get it! 1, 2, 3, yeah! It's your boy Philip here. Talk about the physics of this tidal creek. The variables of temperature, salinity, wave action, wind. They all affect the organisms right here. Because the system is flushed twice daily in a semi-diurnal pattern, that exposes them to different levels of temperature, salinity, and even desiccation. So based on all those parameters, you're only going to find certain organisms in certain spots. Guys, would you check this out? I've got some mud! What it do, bros and broskies? I'm out here in this swamp. You want to call it a swamp? Chilling with some marsh grass, yo. We hanging tight. Okay? You can see there's a couple different types of marsh grass out here. And so why is that? Well, different types of grass, they require different amounts of nutrients. Tidal flushing, elevation, soil type. Okay? And that creates a vertical zonation as you go from the upland, right, where those trees are, down to the ocean. Okay? There are different types of grass. Would you look at this? I found some shells! Hey guys, it's Chester here. I'm in the upland, the terrestrial, or the more freshwater part of the estuary. You can see we've got some trees, we've got some freshwater species, and it's important to talk about what happens way up there, closer to the land, right? And so when farmers, when they put fertilizer like nitrogen and phosphorus, when they put too much of it onto the land, what happens is it gets soaked into groundwater or it gets run off. And eventually it ends up in our estuary. Guys, I found some more mud. I also got here, yo, I got myself a little tidal pool. Yo, check it. Yo, whoa, what it? Oh, come on. Let's go, gang, come on. So this has been Mr. Carlson here at Brownsville, our little mini estuary, studying the chemistry, the physics, the biology, and the geology of this system. Until next time, catch you later.